Welcome back to Coding. So guys, I hope you all are taking care, enjoying the videos that I'm posting for you and understanding each and every concept clearly. Every concise video is present for you to explain you about each and every topic. So do check out the playlist so to understand each and everything. So today, right now we are working on the operating system playlist. So I'm uploading everything that is really important part in operating system and what contents are available in it. So in today's lesson, what we are going to discuss, we are going to discuss about the message passing system, send primitive, receive primitive, CPU scheduling, what is the purpose and objective of CPU scheduling, and what are the different scheduling methods or scheduling algorithms that we can use. We'll be discussing each and every scheduling algorithm in the upcoming video. So also stay tuned for that. So guys, if you're new to my channel, please do like it, share, subscribe to my channel. Already on my YouTube channel, I posted content regarding C, C++, Java, Python, SQL, networking, Excel, and other really important videos that will surely help you out. And if you are a learner, if you are in a college, if you are anywhere studying for anything, so everything you can get over here. All is a free content. Just please support and share it as much with your friend so that everybody gets the content. So let's get started with the video without wasting any time and understand to discuss it. So now coming to the very first thing that we have is that is called as a message passing system. Now what do we mean by a message passing system? As we all know, we are doing communication with the help of some medium that is basically called as a message passing system. So when I'm talking about the message passing system, it requires synchronization and communication between two processes. So the actual function of message passing is normally providing in the form of primitives. So we have two primitives present for it. First is the send primitive and second we have the receive primitive. Now coming to the very first thing, that what is the send primitive? So basically it is used to send message to the destination. A process send information in the form of a message to the another process. A process receives the information by executing the receive primitive, which indicates the source of sending process and the message. So basically what is the send primitive? Basically is used to send a message from the source to the destination, and it sends the information to the process that how the message will be processed. So basically we have two mediums of communication. One is the direct communication, another is the indirect communication. So coming to the very first thing that we have is the direct communication. So in direct communication, how the send and receive primitive work? Send primitive sends m comma message. In this method, send primitive is used for sending message. What is the send primitive used? It is used for sending the message. Sender must specify sender's name. M is the name of the destination and message is the actual data. So whatever we all the things that we need, sender's name, M is the message, and destination, that is the desired thing. So M is the name of the destination and message is the actual data. Here process P is sending process to M. So basically what is the process P is sending message to process M. Second, we have the receive primitive, which is P comma message. In this, a process receive information by executing the receive primitive, which indicates the source of sending process and the message. P is the name of the source which send the message to the process M. So this is the purpose of the receive primitive whenever we are talking about a direct communication. As you can see on the screen also, this is a desired link. So properties of a communication link. Now whenever we are providing some link, we are providing some communication, it also has also link. So links are established automatically. So link is associated with exactly one pair of communicating processes. Whenever you are talking about a link, it will be always compared of some one pair of communicating processes. Between each pair there exists exactly one link. So whenever we are talking about any of the links, so it will include one link. The link may be unidirectional, but usually it is bidirectional. But it can be in any way, but usually it is in bidirectional. The next type of thing that we have is the indirect type of communication. So what is the indirect type of communication? In this method, messages are not sent directly from the sender to receiver, but to share a data structure consisting of queues that can temporarily hold messages. Now what we have in this kind of thing, that we have as a queues in which we can hold temporarily the value. Such queues are generally referred to as mailbox. So which are these referred to as? These are referred to as mailbox. So each mailbox has a unique identification. Two processes can communicate only if they share a mailbox. Now in the previous case, what we are doing, we are directly passing the message, but in this case we will have a mailbox in which the message will be first of all sent, and only it will be done because if both of them have a mailbox. We have taken the send B comma message, it send message to the mailbox B. Receive B comma message, receive the message from the mailbox. As you can see in the screen also, process M1, process M, we have a mailbox in between, that tells us M4, M3, M2, whatever processes are present. Now what are the properties of this? Link established only process share a common mailbox when both the processes have a common mailbox. A link may be associated with many processes. In this case, the link will be associated with many processes. Each pair of processes may share several communication links. So each pair of process, what will do? They will have several communication links. Next thing that we have is the CPU scheduling. Now, whenever talking about the CPU scheduling, basically it is based upon that how the resources are to be managed by the CPU. CPU resource management is also known as CPU scheduling. It is a mechanism which is a part of process manager that handles the removal of running processes from the CPU and selection of other processes on the basis of the particular strategy. Now what it will do, it will check out that which are processes are required to be executed and which are processes are to be terminated or which are processes are being running. So what is the purpose and objective? To increase the CPU utilization. It is responsible for multiplexing processes on the CPU. Now we have a scheduling criteria whenever we are talking about CPU scheduling. It is CPU utilization, throughput, waiting time, turnaround time, response time, and priority. Now, what are these things one by one? Let me discuss. So the very first thing that we have is the CPU utilization. Now, when I'm talking about the CPU utilization, it is defined as an average function of a time during which processor is busy. Now, it will just define that time where the actual process is busy and it cannot work on any other process. The load on the system affects the level of utilization that can be achieved. It may range from 0 to 100. So that is called as the CPU utilization. Second is throughput. It refers to the amount of work completed in a unit period of time. Like it will exactly say like how much time that a processor takes or how much thing that a time take to complete a unit. The number of processes the system can execute in a period of time, higher the number of more work is done by the system. So accordingly the throughput of the system is high. Third, waiting time. The average period of a time of a process depends. Waiting is called as waiting time. It may be expressed as turnaround time less than actual execution time. So basically, it is used to express that how much time does a process take to work from the previous process. Next is the turnaround time. The internal from the time of submission of the process to the time of completion. Whenever we have submitted the desired process and whenever it is completed, that is called turnaround time. It is a sum of periods spent waiting to get into memory, waiting into ready queue, execution on the CPU, and doing input output. So these all things are data included in the turnaround time. Next we have the response time. It is the time from the submission of a request until the first response is provided. Whenever we are submitting a request, how much time it takes to respond back, that is called the response time. Sixth, priority. It gives preferential treatment to process with higher priority. Whenever we are executing a process, it will always give the preference to that process which is of high priority. Basically, as we talked about in CPU scheduling, so basically it works as the way the person works on the things like which priority tasks are to be done earlier and how much time does it take. So all things are to be included in time. So try to link that things into with the real world example. Now we have some scheduling algorithm and scheduling methods. So we have primitive and non-primitive. Now what are primitive and non-primitive? Primitive means in this running processes may be placed by a higher priority process at any time. This scheduling is most responsive but it imparts higher overhead since each process rescheduling initializes a complete process switch. So basically what is it? It takes a more time because we have to change it to any of the process to the higher priority process. Next we have non-primitive. Once the CPU is allocated to a process, the process keeps the CPU until it realizes the CPU either by termination or by switching to the wait state. So that is called as non-primitive. Now we have some of the more important things that are required in algorithms are dispatchers. Dispatcher is also called short-term schedulers. It allocates the CPU to process that is loaded into main memory and then it is ready to run. Then we have the dispatch latency. It is the time taken by a dispatcher to stop the one process and start another process running. That is called as the dispatch latency. I hope you must be clear about it. What do you mean by CPU scheduling? What is the criteria of CPU scheduling? And what is a message passing system? And what are the send and receive primitive? And the different type of message passing, direct and indirect. We will be discussing about the different scheduling algorithm, that is first FCFS, short job first, HJF, round robin, priority, multiprocessor queuing in the upcoming video. So for that, please do subscribe to my channel and also like this video if you like it, and please keep supporting, and also you can check out the other content that are present on my channel. So thank you so much for watching. Keep smiling, take care, and have a lovely